Good afternoon, everyone. My name is Erika Berg, and I lead the application development team at Carbon. We partner with customers to develop end-to-end solutions using our digital manufacturing platform, and last year I had the honor of managing the Riddell development program.
Good afternoon. My name is Vittorio Bologna. I lead the research, design, and development team at Riddell Sports. And in the last year, I had the great success in partnering with Carbon here and intimately involved in the latest project.
We're excited to be here with you today and share a bit about our companies and how we work together to deliver the world's first 3D printed football helmet. Carbon is a global leader in digital manufacturing, and we'll start with an intro on our company. Carbon was founded in 2013, and we're headquartered in Silicon Valley to be in the mecca of high-tech companies. We've grown very quickly in the last few years with over 400 employees and a global install base operating in 14 countries. Our investors include venture capital firms such as Sequoia and Silver Lake, as well as companies who have partnered with us to implement our technology, such as Adidas, J&J, and BMW. We also have a very prestigious set of board members supporting our growth and vision to transform digital manufacturing, including Ellen Coleman, former CEO of DuPont, who is our lead director of the board. She brings an incredible amount of experience in chemical supply chains that is imperative to the success of our business. And Alan Mulally, a leader in business transformation. He's the former CEO and president of Ford and former CEO of Boeing Commercial Airplanes, where he championed the implementation of computer-aided design in the 90s to make the first digitally designed airplane, the 777. It's incredible to see the amount of support we have from our board and our investors as we establish ourselves as a global leader in digital manufacturing. Carbon was the first to introduce a subscription-based business model to the manufacturing industry. And the reason is that a subscription model helps future-proof our customers from the obsolescence of manufacturing equipment, which are significant capital purchases. It also makes it possible for customers to leverage current products without losing the ability to upgrade as new products, resins, or software improvements are released. Our connected hardware can receive over-the-air upgrades and have unprecedented analytics and business intelligence for predictive support and maintenance throughout each unit. Our hardware offerings include the M2D, an entry-level machine for our dental lab subscribers, the M2 and Smart Part Washer, which can be used for exploring prototyping or initial production opportunities using DLS, and the L1, which is 5 times the build area of the M2 platform. The L1 is our recently released product, which is intended for high-volume production. In 2018, the L1s were used to produce over 100,000 pairs of Adidas 4D midsoles, and that volume will continue to increase into the millions in the coming years. And was also used for the initial development and ramp-up for the Riddell SpeedFlex Diamond helmet. With the L1 platform, Adidas and Riddell are 2 of the largest users of 3D printing in the world. A little bit about how Carbon DLS works. Across the hardware offerings, the underlying technology among all of our platforms is consistent. So I'll tell you about how we grow parts. We have a platform to which the parts initially attach and grow out of a pool of UV curable resin. A very thin layer at the bottom of that pool of resin is what we call a dead zone. The thickness of this is about a third of a human hair. And the reason this thin layer is able to exist is because of an oxygen-permeable window. A light engine below the window projects a sequence of images like a movie projector to partially cure the parts being made in a precise and controlled way. So our process is a constant dance of light and oxygen. UV light from a high-performance light engine serves as a chisel to create the shape, and the oxygen inhibits the polymerization process, which enables a continuous flow of resin so that our process can move 25 to 100 times faster than traditional 3D printing methods. This continuous method of growing parts also eliminates the traditional layering process of 3D printing, which means carbon parts have isotropic mechanical properties with exceptional surface finishes. Now, once the part is finished printing, it then undergoes a secondary programmable curing process to trigger a secondary reaction. And this enables the bonds to strengthen and achieve the desired mechanical properties for end-use parts. Not only do we provide the hardware, software, and dual-cure resins for mass production parts, Carbon also supports companies in implementing our technology for scalable solutions. Now, within my team, we work closely with customers like Riddell to understand their product needs, their requirements, and their vision for future products. And we work hand in hand with customers to solve challenges around design, engineering, and manufacturing so that they can have a full end-to-end factory solution. At Carbon, we go above and beyond to make sure our customers are successful in creating some of the best products in the world quickly using DLS technology.
Thank you. So Riddell, the head protection leader, and who are we? I want to go over a little bit of our history, where Riddell has been and where we'd like to go, who founded Riddell and when. So Riddell was founded back in 1929, quite a long time ago, by a high school coach and a high school math teacher, whose name was John Tate Riddell, John T. Riddell. John T. Riddell invented the very first removable cleat and founded Riddell in 1929. So Riddell was a footwear company before it became a head protection company and a football protective company. But fast forward 10 years, and in 1939, John T., being the innovator that he was, came about another breakthrough. He designed, developed, and perfected the very first plastic suspension helmet designed to protect football players. And the U.S. military at the time saw the benefit of the suspension helmet and its benefit to protect the World War II troops, that the suspension helmet and suspension system became one of the most widely manufactured helmets ever. And up until 2007, that same suspension system could still be seen in military combat helmets. So arguably, from 1939 and on, all innovations that deal with football helmets have come from Riddell, whether it be the chin strap, the face guard, the first face guard put on a helmet, air inflation to fit the helmet. The list goes on and on. Up until recently, the precision fit, which is a helmet that uses 3D scans to perfectly match the player's head. And more recently, partnering with Carbon to create the very first 3D printed helmet in football. So how do we do this? Well, we have we have a close-knit team of designers and engineers, a state-of-the-art R&D facility, and the average tenure for our R&D team is 15 years. So we have a lot of experience and knowledge to pull from. Everybody at Riddell is very passionate about football and sporting goods in general, and passionate about protecting the athlete. Leadership at every level. We design, develop, and manufacture helmets and shoulder pads and protective gear for all levels of play, all from the NFL down to the youth level 4- and 5-year-old players. Just a snapshot of where we are in terms of market share in the NFL. 70% of the NFL players chose to wear a Riddell helmet. Even more interesting, more than 600 players chose to wear the precision fit helmet, which is the helmet using scanning technology. So they chose to wear the precision fit helmet, and that is more than all other helmet model, competitor helmet models combined. So it just speaks to the phenomenal success and dedication that we at Riddell have to protecting the player. The precision fit helmet, again, just recently mentioned, using scanning technology, we scan a player's head and make a liner that perfectly matches that scanned player, that player's head. Never been done before in football, and has has had amazing feedback. So, timeline shows where we've been, where we'd like to go in a very few short years. You know, we hear a lot of terms like smart products and data-driven design. Riddell's actually been an innovator in those fields for well over 15 years, starting in 2004 when Riddell launched the SRS system, this acronym for Sideline Response System. This is a helmet that uses 6 accelerometers integrated into the helmet, which is wirelessly linked to a laptop on the sideline. Any impact that that helmet senses automatically gets transferred wirelessly and in real time to the sideline. So from 2004 to date, we have over 6 million impacts in our database that we can pull from and will help us dictate and kind of drive design in future designs. If you look at the dotted line to 2014, we looked at our database, we used the database to inform us on what our shell should be doing, what our liner system should be doing, and we launched the 2014 the SpeedFlex helmet. In 2017, we launched the Precision Fit, going out scanning and scanning players. So from 2017 to 2019, we now have 4,000 head scans in our database of various levels of play. Now, when somebody typically designs a product, you use anthropometric data. Well, we have anthropometric data of football players, so football head scans, 4,000 of them at various levels of play that we can use to design football helmets. It's an amazing resource and amazing data. Where do we go? So 2022, you see in the red font, My Helmet. And Riddell has a plan of every helmet we will be selling in the future will come embedded with a sensor. And the goal is to make sure that all of the helmets that are sold are fitted perfectly matched to the player that's going to be wearing it. Now, what if I said that these sensors, let's throw a little bit of machine learning in there, and have the sensor take a span of playing practices and games, let's say 2 weeks, and it learns and records impact data and creates an impact profile specifically for that player. Now that impact profile can come back to Riddell, and we can use that data to specifically design the impact attenuation properties of the foam or the shell and bring it back right to that player. So now you have a helmet not only designed specifically for a head shape, for a specific person's head shape, but now it's designed to a specific person's or player's head impact profile, which is amazing. Now, how do we get there? One of the only ways we get there is partnering with companies like Carbon, who is able to take that data and digitally design a padding system so we can modify and vary the impact profile of a pad specifically wherever we want within that volume of the pad. So it's an amazing time to be here at Riddell and to be in an R&D.
Yeah, and this has been an incredible partnership. Throughout the program, it was clear that our teams had organic and common working together principles, which enabled us to move quickly and launch an innovative product. We had engaged in transparent teams, we shared data, design logic, test results, and we were able to seamlessly combine our respective digital workflows for an improved product. So now we'll quickly show you an overview video, which we launched earlier this year over the Super Bowl to give you an overview of the product.
We love football. The rivalries, the unbelievable plays, the storied tradition, the wins and the losses. Athletes giving everything for the team, leaving it all on the field. It's the players that make the game and the communities that make it whole. Protect them, and you protect it all. Introducing Riddell Diamond Technology powered by Carbon. Diamond technology replaces the current helmet liner with a 3D printed lattice for advanced impact absorption. Riddell uses 3D scanning technology to ensure a precise custom fit for each individual athlete. Combining this with data from on-field impacts, the Carbon Lattice engine automatically designs and simulates over 1,000 options and selects the optimal liner for each athlete. This custom lattice liner further manages both linear and rotational impact energies. Using a highly damping elastomer, these lattice liners are 3D printed with Carbon's revolutionary digital light synthesis. Grown from liquid, crafted by light and oxygen.
Our partnership with Carbon and the introduction of diamond technology underscores Riddell's continued drive to deliver innovative, on-field head protection to the game of football and its players.
At Carbon, we believe the obstacle is the way. We believe in the power of using technology to solve real problems. Our platform enables companies like Riddell to make products that were never thought possible. We can make the unmakeable. With this partnership, Riddell becomes one of the largest users of 3D printers in the world, and we are proud to be at the forefront of digital manufacturing.
Welcome to the next generation of protective gear for football and beyond, for every sport and every activity, allowing athletes to be bold, powerful, and protected. Protect them, and you protect it all.
We've always known that the future of head protection and the future of our products, it lies with 3D printing. But the industry wasn't quite there yet. We weren't able to manufacture at mass manufacture a product that needs to attenuate energy like a football helmet does. However, a few years ago, we did see the R&D team saw a TED Talk by Joe DeSimone, and the lights went on, and we kept tabs on Carbon until initial contact.
Yep, so in early 2018, we reached out to Riddell and began conversations. The way that our team typically kicks off engagements is we like to have an initial workshop where we sit down, talk about the product, requirements, timeline, overall program objectives, and a number of key requirements that popped up during this initial meeting drove the entire development program.
Sure. So some of the key requirements that Riddell always looks for or sets when developing a football helmet is first and foremost, it's the protection of the athlete, protective capabilities of the helmet itself. Second, of course, is comfort. You need the helmet to be comfortable, or a player is less likely to wear it, of course. And third is, although not a major concern, it's still a concern in the football industry, and that's serviceability. You play in mud, in rain, and to be able to take the helmet apart, the components apart, wash them, put them back together, disinfect them, and send them back to the high school or college is very important. So all of those were requirements that were set when we develop a product.
One thing I heard about for the first time during this initial meeting was the mirror test. And this is an important thing. Vittorio, can you tell us about the mirror test?
Sure. We can develop the best helmet out on the market, and if a player doesn't like the way he looks in that helmet, or she looks in that helmet, again, less likely to wear that helmet. So the mirror test is a very important test, whether it be football or hockey or lacrosse, whatever sport you're designing for. Mirror test is very important, especially when you're on national TV being looked at by millions of people. These athletes definitely want to look good, so definitely an important thing.
Yeah. So we considered all of these factors in the development program. We started out with initial benchmarking tests using pucks, and we quickly transitioned into actual pads that were provided by Riddell. Our latticing software is able to run through thousands of cloud-based simulations, and we would select the best candidates for manufacturability and then ship them to Riddell for in-house testing.
We would take those helmet pads, we would bring them into our state-of-the-art facility. We have linear impactors, for those of you familiar with helmet testing, linear impactors, drop testing, a slew of other equipment that we use to test our helmets. And once we saw the results of the test, we knew that this is definitely a way we wanted to go. And we rushed as fast as possible to get this helmet certified in our lab so that we could put it on the fields, on heads, on different universities and colleges. We have a very close relationship with a lot of Division I schools, and they go out, and once the helmet is self-certified in our lab, they test for comfort and durability and overall, how they like the helmet. Is it better than the one they were currently wearing? Do they like it better? Why? So a lot of feedback that you don't get from in-lab testing. Yes, a helmet can perform great in lab, but once a player wears it, it's a totally different story. A lot of other parameters you have to look through.
I remember hearing about the positive initial feedback, and internally at Carbon, we were really excited about the helmet, and we began gearing up for a product launch. Our engineering and product teams quickly came together to ramp up production for our first set of innovation samples.
Innovation samples, it was an awesome time. We were making helmets for every one of the 32 NFL teams, one for every NFL team out there. And these players professional athletes, elite athletes would put them on their heads, and the ones that chose to wear it gave us amazing feedback. We used that feedback and implemented it in the next iteration of design of the Carbon Diamond Liner.
Yep, and because of our technology, we're able to continue iterating and developing improved products with new lattice structures that will improve impact performance. So I'll quickly walk you through an overview of our production workflow, and then we'll go into details of each section. The process starts with a custom 3D scan using Riddell's proprietary scanning system. Then Riddell analyzes and processes the files, sends them to us at Carbon. We take those files and have created an automated workflow that fills the custom pads with lattice structures, and then prepares a digital file that's ready to print. And then we manufacture the full custom liner on our L1. We do some initial QC in-house, and then we ship the pads to Riddell, where they do additional testing, final assembly, and then they ship the helmets to players.
So Riddell's proprietary scanning process. Riddell learned early on that we needed an app-based system in order to go out and gain mass scans. We were going out with a handheld scanner to NFL teams and Division I teams, and we can do that, and we can service all the Division I and NFL teams. However, to get to the mass population, the 16,000 or so high schools in the U.S., it's not going to happen with a handheld scanner. You need to be able to have your mom or dad or your coach or the player scan his buddies on his Android phone or his iPhone. So we knew that there was a need. This app, we ship hoods to all of the players, and we have them put the hood on their heads, and the hood is screen printed with specific graphics, and every one of those dots are unique. The app takes a series of pictures, about 38 to 40 pictures, and then it takes those dots and uses them as landmarks and remeshes conforms and adjusts the pictures to create a head scan. Now that head scan is FDA approved to plus or minus half a millimeter, which is crazy accurate. Actually more accuracy than we need, but hey, the more accuracy, the better. So we knew we needed this system. We're now rolling it out, and hopefully in the next few years it'll be available to the masses, and kids can scan themselves.
Yep. So then once we receive the files, we use our homegrown software to fill the custom files with the Lattice energy attenuation system. This tool, which we call our Lattice engine, works like a calculator in that we provide the necessary inputs, including a desired energy response and the physical design space, and then the cloud-based software turns through thousands of cell types, shapes, strut thicknesses, and sizes to provide us with a number of potential results that match the given inputs. And this is where Riddell had an advantage because they had data based on 4 million player impacts, including the types of desired responses at various locations throughout the helmet. The lattice is digitally tuned to each part of the helmet, including variable density lattices with gradient transitions across each lattice structure. It provides a desired level of stiffness and softness for precision engineering.
And this is the exact reason why we partnered with Carbon. The way they can variably tune the padding system is phenomenal. You can change the stiffness properties of the foam or the density properties of the foam anywhere within that volume, and is exactly where we plan to go with the My Helmet launch. So again, partnering with Carbon was one of the few ways we were able to do that.
All 7 helmet pads fit on a single L1 platform. And this includes all the sizes of helmets. Riddell has 3 shell sizes that can accommodate the full range of player head sizes. And we've printed and validated every helmet shape and size on the L1. We've worked closely with Riddell to implement every subtle design space changes so that all the pads are self-supporting and can print without the need of support structures to minimize resin waste and print as efficiently as possible. With over 140,000 lattice struts in each helmet, this product is impossible to design or build with traditional design or manufacturing methods. We're thrilled with what we have been able to accomplish in a short amount of time, and we're just getting started.
Riddell believes this is the future of football and protective equipment, and we have a plan to implement this technology from the elite athlete, NFL player, all the way down to the youth level, which is a 4 to 5-year-old player.
So that's what we have for you today. Thank you to the Rapid and TCT team for the opportunity to present on the SpeedFlex Precision Fit Diamond Helmet. If you're interested in hearing more, please feel free to stop by our booth. We'll have the helmet. Our booth number is 731, and we look forward to seeing you throughout the conference. Thank you.
Thank you.